Hi there! In this tutorial, we will be creating a base SDL project that you can use to learn OpenGL and create some games or graphical programs. In order to keep things simple, we will be using the SDL2 library as it's not too complex to learn and it offers everything we need to get started with game or graphical programming. For more information, you can access the libsdl.org page where you will find all the instructions on how to install and use the library. Also, all links mentioned in this tutorial will be available in the description section of this video. So let's get started. The first step is to install the SDL2 library. There are essentially two ways you can do the installation, the manual and the automated way. I will be using the automated way as it saves us some time. Let's first check if SDL2 is already installed in our system. We can do that by typing brew list pipegrep SDL2 and hit enter. As you can see, we don't have the library installed already, so we can install it by typing brew install SDL2 and hit enter. So the installation is almost done. It completed. The installation was done in the user local seller directory, and that's where we will find all our libraries. Let's also install SDL2 image. We might not need this library right now, but later on when dealing with images in general or sprite sheets, etc., we will for sure need this library, so let's install it already. Just a note here, if you already have SDL installed in your machine, you can just update the library by typing brew upgrade SDL2 or brew upgrade SDL2 image. So that will also do the same effect. Now let's move on to the next steps. Now let's create our program's directory structure. We want to create just the minimum necessary to have some organization in place. With that in mind, let's create the following folders. First, the project's root directory, SDL2 starter. Let's now cd into it. And then from here, we also want to create some additional folders. So let's create the build debug folder, the include folder, the lib folder, and the source folder. So at this point, this is how the directory structure looks like. Now that we have our initial directory structure, we want to link the SDL2 and SDL2 image libraries into our application so we can use them later on in our source code. There are many ways on how to do that. For this tutorial, I will be using symbolic links pointing to the real location of the libraries. The advantage here is that if you want to upgrade the libraries later on, you don't have to copy files manually over to your include or lib folders. So let's start doing the linking. First, I will link the SDL2 include folder into our project's include folder. Looking now at the directory structure, we can see the link between the folders. Now let's create the link between the include folder of the SDL2 image library into our include folder. Just double checking the linking. We can now see the two links done. Let's do the third one, which is the linking of the SDL2 image lib folder into our project's lib folder. Alright, let's just have a look at the final linking. So we can now see all the three links done correctly. At this point, the directory structure is complete. Let's just create two additional files we will need before we go to the next step. Let's create the source main.cpp file. And let's also create the Makefile in the root of our projects folder. Let's just check it out one last time so we can see all the initial structure done and the two files that we will need to move on. Alright, so at this point we are ready to open our code editor and proceed to the build and debug setup. I will be using VSCode here, so the configuration process I'll go through will be also relative to this particular IDE. So just keep that in mind. So let's open VSCode. So let's first check out if we have the C++ extension installed, because we will need it. So if you don't have it, please install it first. Is the C++ extension from Microsoft. And then if you have it, we are ready to proceed to the next step. Let's now open up our Makefile and configure the script to build our application. Let's first create some variables that we will be using later on to create the final build command. So the first variable that we would like to create is the source dir variable, which will be pointing to the source folder in our project. Now let's create the build dir variable, which will be pointing to the build/debug directory. Now let's create the compiler command variable, which in our case will be the G++ compiler we will be using initially. You can change it later on. Let's create now the source files variable, which will actually select all the files within the source directory. So we will be using the source dir variable here that contains the extension .cpp. So instead of having to add all the files one by one here manually, we can use this wildcard selector to create the list of files that we need and store this list in the source files variable. So we can do that by using this wildcard selector. Then we use the existing variable source dir, and then we just select all the files with the extension cpp. The next variable we would like to create is the object name. That will be the name of our executable file, the end file that will be generated. Let's call it play. Now let's create the include paths that we want to inform to our compiler. So this will be the directories that the compiler will look for include files. In this case, we will only want to include our project's include directory. Now let's create the library paths, which will also point only to our lib directory of our project. Next step, we want to create the compiler flags variable, which will will be used to set the flags that we would like to pass or define when compiling the application. Here I will be using the C++11 as the standard version. We want to have all the warnings outputted to the console. We want to disable any optimization, and we want to enable debugging on the final object that will be generated. And the last variable we want to create is the linker flags variable, which will have the link to our SDL2 library. Okay, now that we have all the variables that we need, we can proceed to the creation of the build command, which we will call all here. And we will use the variables to create the command. So first, the compiler command. So that's the first one we want to have. Then we will follow this one with the compiler flags. After the compiler flags, we want to pass on the linker flags, then the include paths and the library paths. Then the source files we would like to compile. And finally, the output directory, which will be our build_dir/obj name. And that's it. So that's the command that we will need to make our application to build it. And if you need later on to change it, it's quite easy and intuitive. So now let's add some code to our main.cpp file just to test our Makefile to see if we can build our application. So let's just add some simple code here. Let's create our main entry point, and let's just print something to the console here. So let's create a variable called greetings, hello SDL2. Let's output that to the console. And let's return successfully from our application. Now we can test our build script and build our application. And as you can see, this is the final command that we generated from our Makefile to build the application. And now we can test our application to see if it works. First, let's check if we have it in the right place. So it was created in the build debug directory. Let's now execute it to see if it works. And it does. We can see the hello SDL printed to the console. So at this point, we have our application being built correctly. Now let's set up the debug of our application. Go to VSCode menu, run, add configuration, and select C++ GDB LLDB. In the next list, select G++ build and debug active file. This will create a launch.json file for us, like this one we are seeing here. We will need to modify a couple of things in it. So let's start doing these adjustments now. Let's change the name property to debug. The type we don't change. We don't need to change the request type. We want to change the path to our program to point to our build debug play object. We can use here as a reference our workspace folder and then point to our build debug play object. We don't need to change or add any arguments here. We don't need to change the stop at entry, and we want to change the current working directory to also point to our workspace folder. The other parameters we leave as they are, and we want to use a pre-launch task which will be called build. This pre-launch task will be called every time we launch our application, and we run it before it, so we make sure that we are running the latest version of our code. So now we can try to run, and we will get this pop-up here saying that we don't have the build task. So we can actually just click configure this task and a template will be shown to us. We want to change a few things here as well, so we don't need to change the type. The type should be CPP build, that's correct. We want to change the label though, so the label should be the same name as the pre-launch task, so that's how those two connect. And we also want to change the command here, so we want to reuse our Makefile, so we don't need to create again or duplicate the command to build our application, because that was already done before in our Makefile, so we can just use the make command here. We want also to use the workspace folder as our current working directory. And for the problem watcher, we don't need to change. The group will still be build, and that's the default group. And we can just give a slightly better description to our task. And that will be it. So once that's done, we will be ready to debug our application. Let's now open up our main CPP file and add a breakpoint to line 6. We can then click to debug our application. We just need to wait a little bit. We can check the output in the debug console. The application is being built, and there you go. So the application is started and stopped at line 6. We can also see here on the left side the variables that our application has and their values. We have access to the call stack as well if necessary, and we can then press F10 for instance to move to the next line, and we can also check the output here in the debug console. We can now just continue the execution of our application and let it run until the end, and then we can see that we exit the application with code 0 successfully, no errors. So that's very good. Now let's test one last thing. So let's use some SDL code in our application to see if everything is working fine. So let's include the SDL header into our main.cpp file so we can have access to the SDL functions. Let's initialize SDL. So for now, let's just initialize everything. Let's test if the initialization went well. So if something goes wrong, you have negative numbers, and if everything went well, then you will have a return that it's positive. If something went wrong, we want to output the error to the console so we can understand what happened. We can also get the error from SDL get error function. And we can then just return or complete our application at this point with exit failure, indicating that there was some issue. Now we can debug our application again to observe that the build will be successful and we will be able to be using SDL functions within our source code, indicating that we are also able to use properly SDL code in our application. We can also see that the breakpoints are working. We can just run our application and see also the output being printed to the console. And that's it. So at this point, the SDL starter is properly configured to be using SDL2 and running on a Mac using VSCode. Congratulations. There's one last thing we need to do here that I missed, which is to quit the SDL subsystems that we initialized early on. We can do that by calling the SDL quit function, which will take care of the initializing everything that we initialized with the SDL init function. So we don't leave any memory leak or we make sure that our application exit and releases all the resources that have been allocated so far. Let's compile it again. So as you can see, it compiles without any problem, and that's it. If you made this far, thank you so much. I really hope that this helps you to start learning OpenGL and using SDL2, which was one of the libraries that you can use, but later on you can of course explore other types of libraries. And in case you liked, please don't forget to leave a thumbs up or to subscribe to get notifications for upcoming tutorials. See you next time.